Geometry nodes is a pretty handy tool when you need to automate things, and muzzle flares are definitely something that it could be used for. So let's make a stylized flare generator. Select the default cube, head over to the Geometry Nodes workspace, and add a new node tree. Add a points node, an instance on points node, a curve line node, and an align Euler to vector node. This creates a number of curves equal to the amount of points in the points node, and aligns them along the x-axis. With this as a base, we can add some randomness to the alignment to create a controllable spread. Add a vector math node set to add, and a random value node set to vector. Set the first two values in the min and max fields to -1 and 1 respectively, and set the third values to 0. Then connect it to the vector add node. Now that we have a random spread, we can add some manual control to it by adding a vector math node set to scale after the random value node, with the scale value now controlling the size of the spread. Next, let's add some randomness to the size of the curves. Add a random value node, and a math node set to inverse square root. Set the min value to 0.1, then connect the math node to the scale input of the instance on points node. The reason for the math node is that it creates a more interesting scale pattern than just using the random value. Now that we have a good spread and scale distribution, let's turn the curves into something that looks more like a flare. Add a curve to mesh node, and a curve line node, and connect it to the profile curve input. Then set the start x to -1, end x to 1, and the other values to 0. A plane like this isn't what we want, but luckily, we can create essentially any shape we want along the curve with just a few more nodes. First, add a resample curve node with a count value of 6. The more points available on the curve, the more precisely we can shape the resulting mesh. But since we just want something vaguely flame-shaped, a resample value of 6 is enough. Add a set curve radius node, a spline parameter node, a float curve node, and a math node set to multiply. With this setup, we can now create a custom shape by adding and moving the control points in the float curve node. And with the multiply node, we can control the overall thickness. This is starting to look like a flare now. We just need to do something about the uniform alignment of the flares. To do this, add a rotate instances node, and a random value node set to vector. The axis that we want to rotate is the z-axis of the instances. So set the z values in the random value node to something like -pi and pi. If you wonder why we rotate along the instance's z-axis and not the x-axis, it's because any adjustments to rotation, location and scale aren't applied to instances until they are realized. And since this is what the instances are looking like without any transformations added to them, it hopefully becomes clear why we rotate on the z-axis. With the flare constructed, I would like to add some distortion to the mesh. To do this, add a realize instances node, a set position node, a noise texture, and a map range node set to vector. The noise from the noise texture is being used to displace the mesh, but since the noise values go from 0 to 1, the resulting displacement is heavily biased towards the positive x, y and z axis. To fix this, Set the two min values and two max values to -0.1 and 0.1 respectively. This both cancels the positive bias and makes the displacement less intense. Next, let's add a material so we can make the flare emissive. Add a new material in the Materials tab and name it Flare. Then in the node tree, add a set material node and select the flare material in the dropdown. In the shading workspace, let's make a simple flare shader. Add a noise texture and a color ramp. Set the scale to something like 1.5. Change the colors in the color ramp to some more fiery colors. And move the color stops closer to each other. Next, connect the color ramp to both the base color input and the emission input. Then increase the emission strength to something like 5. Now that we have a setup that creates a flare shape, we can add some functionality to the node tree that allows us to procedurally animate it in a way that lets us control the firing rate with a single value. First, we need to make the shape change every frame, and the solution to that is actually very simple. Anywhere that we use a random value node, we can use the frame output of a scene time node as the seed to get a new random value every frame. So do that for the random value controlling the instance rotation, and the random value controlling the instance scale. I will also add a random value node for the spread scale, with a min value of 0.2 and a max value of 0.8. And use the frame value for the seed there as well. This is just to add some more randomness to the shape. This is what it looks like when I press play on the timeline at 60 FPS. Pretty good. However, if I change my viewing angle, you can see that there is still a static shape in the flare that we need to take care of. So let's do that. After the set position node, add a geometry to instance node and a rotate instances node. The quickest fix is to change the X rotation of the flare at every frame. And to do that, we just need to add a scene time node and a combine XYZ node, and use the frame output as the X value in the combine XYZ node. Now if I play the animation again, the static shape is gone. Now, this works fine for something like a Gatling gun, but we probably want to be able to turn off the flare for slower rate of fire. To do this, we can use a switch node to switch between the flare mesh and nothing. To control this procedurally, add a scene time node, a math node set to wrap, with a max value of 16 and a min value of 0, and a compare node set to integer and less than or equal. The max value in the wrap node now controls the gap between each flare, and the b value in the compare node controls how many frames the flare should be visible. Pretty neat. However, while this works fine for a constant rate of fire, you probably want to be able to control it completely manually with keyframes too, so let's make a manual variant too. The only difference here is that instead of controlling the switch with frames and math, we will expose the switch value to the modifier, where we can keyframe it like any other property in Blender. Add a group input node and connect the switch input to the group input. This adds a switch value in the modifier tab, which we can keyframe by hovering over the value and pressing I. And that's about it. Now you can just parent an object with the geometry nodes modifier to whatever weapon you want some flares for, and either use the automated firing setup or the manual setup depending on the situation. I hope you found this video helpful, and that you learned something new. See you next time.